Comparing snapshots literally is picking up a sort order or ID generation difference. Let me find the actual delta. The only divergence is
Editing test
UUID
scope
node ID.
equilibrate.
Substrate state is otherwise. All
Running
three pass.
CD.
Phase 1, 2. Quick safety check. Existing tests still pass with the new scope param.
Writing scope.
No regressions. Now phase 1, 4, the scope helper.
Using task update. Using task update.
Now phase 1.
Writing test
5.
scope helper.
The test
Running
confirming
CD.
scope for observation matches the existing bandwidth gate behavior. All 5 tests pass. Phase 1, 4 plus 1, 5 done. Pausing here to give you a status check before proceeding to phase 1. 6. Autonet integration. That's where we touch the production daemon and want eyes on the deploy seam. Completed foundation done, all tests green. 1. 1. Scope param in equilibrate plus applistates, backward compatible 1. 2. Scope equals none preserves baseline, 3 tests 1. 3. Scope equals subset isolates out of scope tendencies 1. 4. Scope for coords / scope for observation helper in world model / generalized / scope. Pi 1. 5. Helper agrees with existing cross-tendency edge discovery. 5 tests. Next up, phase 1. 6. Wire into world service. Pi. Submit observation with a config flag for a /b. Want me to proceed, or anything to adjust first?
Using task update. Finding files matching C /code /autonet /node /common /world survey. Searching for def submit observation. Equilibrate def s. Reading world service. Reading world service.
Now I need to find the world service
Searching for
config
default
seam, where
equilibrate,
default's
embedding
live,
dim
and
chop.
check how
Reading
charter
world
coords
service.
project relative to scope. Good, now I have the
Reading world
seam.
service.
3 call sites use
Editing
equilibrate.
world service.
Submit submit observation, and equilibrate itself. Adding the config flag and threading scope through submit observation, the launch block. Now
Editing
wiring
world
the
service.
integration. Plan. Closing
Using
1.
task update.
5 test was already done earlier, keeping 1, 6 in progress. Now the actual call
Editing
site,
world service.
change in submit observation.
Running CD.
Now let me
Running
verify it
CD.
imports cleanly, and no autonet tests, reference world service. Autonet has a
LS.
vendored copy of world model at world
Running
model.
diff.
I need to mirror the scope. Pi change there. Architectural
Running
snag.
diff.
Autonet coordinate frame. Pi differs between the two. The two repos have drifted independently. Wholesale sync, option 2, would silently overwrite Autonet's drift. That settles it, option 1. Targeted mirror is the safest. I'll port my 3 additions, scope, pi creation plus equilibrate, pi plus world, pi changes into the vendored copy. The 2 copy situation is real tech debt, but resolving it isn't this task. Pausing for your call, proceed with targeted
Reading
mirror.
equilibrate.
Or do you want a different approach, e.g., make the world model repo the single source of truth and resolve the drift first? Mirroring the 3 additions into the vendored copy. Sorry, sloppy phrasing. Let me be more precise. What I observed, 2 physical copies of the world model package exist, world model \, the standalone repo, what test, pi files import, what I edited in phase 1. 1. World model \, a copy vendored inside Autonet, what production world service actually imports via from world model, generalized import. When I checked coordinate frame, pi differs between the 2 copies. That tells me at some point, someone edited the Autonet vendored copy directly rather than syncing from the upstream repo. They've drifted. What I meant by single source of truth. In a healthy setup, 1 copy would be canonical, the standalone repo.
Running diff.
Pure perf tweak, a single pass rewrite of the same logic. Same output faster. Someone profiled the hot path inside Autonet and inlined the loop in the vendored copy, and never ported it back upstream. That's the kind of drift I'm flagging. So no, I wasn't talking about charter root counts. I was talking about the engine code itself isn't identical between the 2 places production uses it and the standalone repo I just edited. The fix for this task is the targeted mirror. The longer-term question is whether to consolidate, but that's a separate decision, not something we need to settle right now. Proceed with the mirror. No, opposite direction. I'd be mirroring my new changes from world model right arrow into Autonet's vendored copy, so the daemon actually picks them up. The 3 files to port from world model / to generalized / equilibrate. Pi add scope param generalized / world. Pi add scope param to applistake's generalized / scope. Pi new file, the helper I would not touch Autonet's coordinate frame. Pi perf rewrite. That drift stays where it is, it's a separate problem. The other direction port, Autonet's coordinate frame. Pi perf tweak right arrow back upstream is real cleanup but not this task. Proceed.
Editing world service. Editing world service. Editing world service.
Fair, you're right to
Running
call that
CD.
out. I've been working in both. The phase 1, clean,
Using task
Autonet
update.
reverted to base. Status, Autonet repo, reverted untouched. World model repo, phase 1, 1.1, 5 complete scope param plus helper plus 8 tests passing. Tasks reorganized. 105/106/110/111/115 marked deferred to a later Autonet consolidation phase.
Autonet.
Running diff.
Quick scan of the whole
Reading
package,
vendored.
not just
Running diff.
generalized slash. Verdict: the drift is interesting slash uninteresting. It's the boring kind. Pure perf optimization. Same function, same output, single pass instead of two pass, avoids the abs, call. No semantics changed. Vendored, MD is explicit. Autonet copy is a vendored mirror, source of truth is. The convention says, edit upstream, sync downstream. Someone violated that convention to inline a perf tweak. Recommendation: port the perf tweak back upstream in its own commit, separate from any scope work. That eliminates the drift, restoring the vendored copy invariant. Keeps the autonet tweak. It's a real hot path win. Coordinate frame is called inside tendency. Act, which is exactly what our scoped equilibrate work is about. Costs ~5 minutes. Want me to do that as a small detour now, or cue it as a follow-up after phase 1? 8. Right, porting
Reading
autonet's
coordinate
coordinate frame. PyPerf rewrite right arrow world model upstream.
Editing coordinate frame. Running diff. Running CD.
Drift resolved,
Using task
coordinate
update.
frame.
Reading run
PyPerf
tier
rewrite
3B.
ported up. Looking at the tier 3B runner to
Reading
understand
run
what to
tier
modify.
3B.
Equilibrate call is at
Reading
line
run tier
135.
3B. Reading
To
run tier
verify scoped
3B.
equilibrate preserves tier 3B's findings, H2, H3, H4, I'll create a focused mini-runner that reuses cached LLM responses, no fresh API calls. We already have tier 3 BLLMA cache. JSONL and tier 3 ALMA cache. JSONL runs only the haiku times 6 root condition, the most signal-rich, the one that proved tier 3B. Runs it both ways, with and without scope equals. Compares H3 plus
Writing
H4
verify
metrics.
scope tier 3B.
A regression in
Running
either
CD.
metric is the signal that scoping costs cross-domain signal at this scale.
Running CD.
I have enough. Writing a focused validation script that runs the haiku times 6 root condition twice. This script puts
Editing
both world
verify
model
scope
and
tier
autonet on
3B.
SIS.
Running
Path.
CD.
The autonet world model is shadowing the upstream one. Let me check ordering and swap. Right, Autonet's world
Editing
model
verify
wins because
scope
the second
tier
insert,
3B.
0, puts Autonet first. The verify script needs world model to win for scope, Pi to be importable, adjusting path order in the verify script.
Editing verify scope tier 3B.
Findings
Running
interesting but
CD.
mostly good news. H4 categorical separation, identical to 4 decimal places. Scoping doesn't lose the architectural property we care about, that's the load-bearing one. H3 STDDev, drifted plus 27%, but in the helpful direction. Unscoped equals 8,090, scoped equals 10,244, scoped produces more separation. Phase
Using
1,
task
8,
update.
pass. Headline results, H4 categorical status check before continuing. Phase 1, scoped
Running
equilibrate.
ls.
Done. Engine. Scope param on equilibrate plus applistics. Scope
Running
computation
find.
helper. 8 unit tests passing. Coordinate frame. Pi drift resolved. Tier 3B
Running
verification.
WC.
H4 preserved exactly, no sign flips. Remaining world model work. Phase 2. 1 plus 2. 2. PCA dim sweep. 1024 right arrow 128/64 using existing corpus. Phase 3. 1 plus 3. 2 plus 3. 3. Slow Lindblad exploration mode plus subclaim writeback plus cross-domain test. Deferred to autonet consolidation phase. 105, 106, 110, 111, 115. Proceed to phase 2. 1 PCA dim sweep or pause here. Looking at the existing event corpus, 1,183 work units in WorkUnitSol, JSONal. But those don't have category labels. H4 needs capability imability vs reasoning heavy categorization. The Tier 3B 30-turn corpus does have labels. Let me reframe. Phase 2. 1 plus 2. 2 reframed. The right experiment is to use the labeled Tier 3B corpus, which already produced H4 equals 0. 816 at 1024 dims, and ask, at what dim does H4 hold? The Tier 3B corpus uses binary flag LLM coords, 6 dimensions, not 1024, for the substrate axes themselves. The 1024 dim embedding is the embedding tail, used by the rootless usefulness path in autonet, but not exercised by the Tier 3B benchmark, which only feeds the 6-axis charter head into observations. Reading post-atone findings. MD 33 confirms. Embedding tail is 1024 dims, sentence transformers mini LM. Total per event coord vector is 1030 dims. But Tier 3B was run with 6-axis coords only, no embedding tail. My phrasing, autonet-shaped, meant the code that uses mini LM lives in autonet, not in world model. Concretely, mini LM is consumed by usefulness coords. Pi, the default usefulness emder you can see imported in world service. Pi. World model itself doesn't import sentence transformers anywhere. It just takes whatever coord vectors callers hand it. The mini LM 1024 right arrow PCA reduce, right arrow 256 pipeline lives entirely in Autonet's wrapper layer. So when I said autonet shaped, I meant editing usefulness coords. Pi to add a target DIM projection is editing autonet code, not world model code. And under your world model first, consolidate later rule, that's something I shouldn't touch right now. And this is the part where the framing was off. Measuring at what DIM H4 collapses doesn't require editing autonet at all. It just requires using sentence transformers from a standalone script. The library is pip installable. We can pip install sentence transformers in this directory. Write a measurement script that calls mini lm directly, project and substrate in measure, and never touch autonet code. The autonet edit only comes later, phase 2. 3, deferred, when we go to wire the chosen DIM into production. So my recommendation, C. Use the tier 3B30 turn corpus, encode with mini LM, PCA reduce, measure category separation, is purely a measurement script in substrate experiment /phase 2 /. No autonet edits. Just answering, at what DIM does the discriminative power collapse? Proceed with that. Understood. Let me lay out the actual situation cleanly so you can pick. What's where world model, the engine tendency, pi world, pi equilibrate, pi Lindblad, pi coordinate frame, pi etc. This is what I edited in phase 1. 1. Autonet, a vendored copy of world model under world model / sync convention per vendored, MD. Plus autonet-specific wrappers that don't exist upstream, node / common / world model substrate / adapter, persistence, mintgate, outcomes, usefulness coords. Pi the mini LM wrapper, nodes / common / world service. Pi, the daemon lib2p gossip, epoch reconcile, etc. The mini LM wrapper isn't drift. It's something that only exists in Autonet, because the upstream world model engine never had any opinion about how callers compute coords. The engine takes whatever vectors you hand it. The actual fork in the road, you have two paths. Path A, stay in world model only. All remaining engine work, slow Lindblad, subclaim write back, cross-domain test, PCA dim measurement, happens in world model. PCA dim measurement uses mini LM as a standalone library. Pip install, used from a script in substrat phase 2 /. I never touch Autonet. When all engine work is done, you do one consolidation pass that ports world model right arrow Autonets, vendored copy, and wires the new APIs into usefulness coords. Pi/world service. Pi. Path B, move usefulness coords. Pi upstream into world model. The mini LM wrapper isn't Autonet specific. It's how callers compute coords from text, a perfectly reasonable thing for world model to ship. Move it upstream, then everything I need is in one place. Autonet imports it from there going forward. This permanently shrinks the Autonet surface area. Path A keeps me in world model and never talks about Autonet again until the consolidation pass. Faster to your stop mentioning both goal. Path B is structurally cleaner. It removes the artificial split that's been causing the confusion, but it's a one-time refactor that touches Autonet to move code out. After that move, all future engine work is purely in world model forever. My vote, A if you want fastest path to one project at a time, B if you want to fix the underlying split. That's a clean third option. Let me think it through. Path C, port what we need upstream, leave Autonet untouched. What we need actually is, concretely, usefulness coords. Pi, the mini LM wrapper, hashing embedder, sentence transformers embedder, default usefulness emder, coords for problem resolution, coords for query possibly adapter. Pi, absid from turn if our experiment scripts call it, which they do, in Tier 3 BLL madapter. Pi, 25 and verifiscope Tier 3B. Clear, path for the
Using
work with
task
an
create.
explicit consolidation checkpoint at the end. The consolidation step is just 2 commands. Now phase
Running
2.
CD.
1. PCA dim sweep. Standalone script using sentence transformers as a library. Living in the experiment directory, not autonet, not world model, it's an experiment. Good, library is already
Reading Tier
installed.
3A corpus.
Now checking how Tier 3A corpus. Pi formats turns so I can extract text to embed. Each turn is a dict
Writing
with
dim
type
sweep.
/tool
Running CD.
/command /description fields. To embed, concatenate the meaningful fields into a single string.
Running CD.
Write PCA
Editing
can't
dim
project to
sweep.
higher than min,
Editing
n
dim
samples
sweep.
equals 30, n features equals 384 equals 30. With only 30 turns, the dim ceiling for PCA is 30. 2 options. Cap target dims at min n samples, n features, 1 equals 29. Use a larger 240
Editing dim
work
sweep.
units across
Running
6
CD.
projects, treating projects as natural categories. That gives PCA enough samples. Updating the script to use this corpus. Result clean.
Using
Dim
task
mean
update.
cat dist retain. Status
Using
phase
task
1
update.
scoped equilibrate. Done. Phase 2 dim sweep. Done. Recommendation equals 64 dims, 95% retention. 6 times speed up vs native 384. Phase 3 slow Lindblad. Pending. Consolidation sync to autonet wire deferred tasks. Queued.
Using task update.
Phase 3 is pure engine work. Slow Lindblad exploration pass plus subclaim writeback plus cross-domain
Editing
test.
equilibrate.
No autonet involvement. Proceed to Phase 3, 1.
Using task update.
Phase 3,
Using
1.
task update.
Exploration mode Lindblad wrapper. Now Phase
Reading
3,
equilibrate.
2.
Reading
Extend writeback
equilibrate.
to emit subclaim level crosslink stakes for high J pairs. Now I need the crosslink
Editing
emission
equilibrate.
logic. Quick
Using
smoke,
task
imports
update.
and existing Lindblad tests still work. Good, Phase 3, 2 done. Now Phase 3, 3. Test that confirms slow Lindblad surfaces across domain link the discrete kernel missed.
Writing test Lindblad crosslink.
The test needs
Running
a world where
CD.
two subclaims sit just outside each other's bandwidth. Scoped equilibrate doesn't link them, but coord close enough that the Lindblad Gaussian kernel exp d2/2bw2 gives non-trivial jab. Subclaims sprouted from different roots with bandwidth equals 0, 5 sitting at distance ~1, 0, 1, 5 from each other. That's outside bandwidth *1, 5 equals 0, 75 but exp -1. 0, 2/. The crosslink
Editing
emission
test
picked a different
Lindblad
pair than I
crosslink.
expected.
Running
The
CD.
world has more than just suba and sub. Discrete equilibrate has been sprouting derived subclaims under each root. The observations themselves create child nodes via all world model engine work is done. Final tally, every test passing. Phase 1, scoped equilibrate. 3 unit tests plus 5 helper tests plus Tier 3B verification all green. Phase 2, PCA DIM sweep. 64 DIMs recommended, 95% retention, 6 times constant factor win vs 384. Phase 3, slow Lindblad exploration. 3 crosslink tests pass. Existing tests, co-parenting Lindblad equilibrate, no regressions. What's left all batched under one autonet phase, task #116, sync C, world model / right arrow C, world model / prevendered, MD. Wire scoped equilibrate into world service. Submit observation, #105. Add target dim equals 64 projection to usefulness coords, pi, #110. Migration test for existing 1024 DIM events on disk, #111. Adaptive trigger in world service for the slow Lindblad pass, #115. Seed time benchmark to confirm the O-N shape, #106. Stopping here, engine work is complete. Autonet consolidation phase is next and well-defined.